Space is vast, bigger than vast. It's full of stars, planets, and galaxies. But did you know there are planets out there that don't orbit a star? These are rogue planets, cosmic wanderers drifting through the darkness. They are mysterious objects holding secrets about our universe. Imagine a planet similar in size to Jupiter but with no star to warm it. It exists in a perpetual night, its surface possibly covered in frozen oceans or strange alien landscapes. These rogue planets challenge our understanding of planetary systems. They offer a glimpse into a different kind of planetary evolution. The study of rogue planets is a new frontier in astronomy. As we discover more about these cosmic nomads, we learn more about the formation and evolution of planets, including our own. What exactly are rogue planets? Simply put, they are planets that don't orbit a star. They are like planets that got lost in space, drifting alone in the darkness. In our solar system, planets orbit the sun. The sun's gravity holds them in place, dictating their paths. Rogue planets, however, are not bound to any star. They wander through interstellar space, free from the gravitational pull of a host star. These planets are often called free-floating planets, orphan planets, or interstellar planets. No matter the name, they all share one defining characteristic. They are alone in the vastness of space. But just because they are alone doesn't mean they are not interesting. In fact, rogue planets might be some of the most common objects in the universe. Where do these rogue planets come from? Astronomers believe they form in one of two ways. The first is similar to how stars and planets form in our solar system. A cloud of gas and dust collapses in on itself, forming a disk. At the center of this disk, a star ignites. The remaining material clumps together, forming planets. Sometimes during this chaotic process, a planet can be ejected from the system, flung out into interstellar space. The second way rogue planets can form is through a process called gravitational collapse. In this scenario, a cloud of gas and dust is not massive enough to form a star. Instead, it collapses directly into a planet. This planet is born without a star to orbit, destined to wander the galaxy alone. Imagine a young planetary system still in its infancy. The planets are jostling for position, their orbits unstable and chaotic. Gravitational interactions between these planets can be violent. In some cases, these interactions can be so strong that a planet is ejected from the system altogether. This ejection process is thought to be a major source of rogue planets. It's like a cosmic game of billiards, with planets as the balls. One wrong move, and a planet can be sent careening off into the darkness. The ejected planet, now a rogue, is left to wander the galaxy on its own. It carries with it the secrets of its formation and the story of its violent past. Section 5. Finding the unseen, detecting rogue planets. Detecting rogue planets is a challenge. These elusive celestial bodies drift through space without orbiting a star, making them incredibly difficult to detect. They emit no light of their own, making them incredibly faint and difficult to spot against the backdrop of space. Unlike stars, which shine brightly, rogue planets are dark and cold, blending into the cosmic darkness. So, how do astronomers find these cosmic wanderers? The answer lies in advanced techniques and innovative methods that allow scientists to detect the subtle effects these planets have on their surroundings. One method is through a technique called gravitational microlensing. This fascinating method leverages the gravitational pull of massive objects to reveal hidden planets. This method relies on the fact that massive objects like planets can bend the fabric of space-time. When a rogue planet passes in front of a distant star, its gravity acts like a lens, bending and amplifying the star's light. When a rogue planet passes in front of a distant star, its gravity acts like a lens, bending and amplifying the star's light. This temporary brightening of the star is a telltale sign that a rogue planet is passing by. Astronomers observe this brightening of the distant star, even if the rogue planet itself is too faint to see directly. By carefully monitoring these changes in brightness, they can gather crucial data about the rogue planet. By studying the characteristics of the lensing event, they can infer the presence of the unseen planet and estimate its mass. This data helps scientists understand the nature and distribution of rogue planets in our galaxy, shedding light on these mysterious wanderers of the cosmos. Section 6. Gravitational microlensing, bending light to find hidden worlds. Gravitational microlensing is a powerful tool for finding rogue planets. It's like using a magnifying glass to search for something small and hidden. The gravity of the rogue planet acts as the magnifying glass, amplifying the light from the distant star. This technique is sensitive to planets of all sizes, even those much smaller than Earth. It can also detect planets that are located far from their host stars, including those that have been ejected from their systems. Microlensing surveys have revealed that rogue planets might be incredibly common in the Milky Way galaxy. Some estimates suggest that there could be billions or even trillions of these cosmic wanderers drifting through interstellar space. Section 7. The importance of rogues: what we can learn. Rogue planets might seem like insignificant objects lost and alone in the vastness of space. These wandering worlds, untethered to any star, drift through the galaxy in solitude. But they hold valuable clues about the formation and evolution of planetary systems, including our own. These planets, often shrouded in mystery, can reveal secrets about the early stages of planet formation and the dynamic processes that shape their destinies. By studying rogue planets, we can learn about the conditions in which planets form and the processes that can lead to their ejection from their systems. Observing these planets can help us understand the chaotic environments of young planetary systems and the gravitational interactions that can send planets hurtling into interstellar space. We can also gain insights into the diversity of planets in the universe, including those that might be very different from the planets in our solar system. The study of rogue planets expands our knowledge of the myriad ways in which planets can exist, offering a broader perspective on planetary science. Furthermore, rogue planets could potentially harbor life. Despite their isolation, these planets might possess the necessary conditions for life to develop and thrive. While they lack a host star to provide warmth and light, some scientists believe that internal heat generated by geological processes could sustain life on these planets, perhaps in subsurface oceans or other extreme environments. The possibility of life on rogue planets challenges our understanding of where life can exist, and encourages us to look beyond traditional habitable zones. Section 8. A galaxy teeming with wanderers: the abundance of rogue planets. The more we study rogue planets, the more we realize just how common they might be. These planets, which drift through space without orbiting a star, are fascinating objects of study. They challenge our traditional understanding of planetary formation and dynamics. Microlensing surveys suggest that they could outnumber stars in the Milky Way galaxy. This technique, which involves observing the bending of light from distant stars, has revealed the presence of many rogue planets that would otherwise remain hidden. This means that there could be billions or even trillions of these cosmic nomads drifting through interstellar space. These planets, untethered to any star, wander the galaxy, potentially carrying with them the secrets of their origins and the history of their journeys. This abundance of rogue planets has profound implications for our understanding of the universe. It suggests that planetary formation is a more common and chaotic process than previously thought. The sheer number of these planets indicates that the processes that create and eject them are not rare events. It suggests that planetary systems are dynamic and chaotic environments where planets can be ejected from their systems relatively easily. This ejection could be due to gravitational interactions with other planets or stars, or even close encounters with passing celestial bodies. The vast number of rogue planets also raises intriguing possibilities about the potential for life beyond Earth. These planets, with their diverse environments, could host life forms that have adapted to extreme conditions, far from the warmth and light of a star. While the conditions on these planets might be extreme, the sheer number of them suggests that life might have found a way to survive on at least some of them. The discovery of extremophiles on Earth, organisms that thrive in the most inhospitable environments, supports the idea that life could exist in the harsh conditions of rogue planets. As our technology advances, we will continue to uncover more about these mysterious wanderers. Future missions and more sensitive instruments will help us detect and study rogue planets in greater detail, revealing their secrets and expanding our understanding of the cosmos. Section 9. Conclusion: the future of rogue planet hunting. The study of rogue planets is a rapidly evolving field. As telescopes become more powerful and detection techniques improve, we can expect to discover many more of these cosmic wanderers in the years to come. These discoveries will continue to challenge our understanding of planetary formation and evolution. They might even provide us with the first evidence of life beyond Earth, albeit in a very different form than we might expect. The future of rogue planet hunting is bright. These cosmic wanderers, once thought to be rare and insignificant, are now recognized as a crucial piece of the cosmic puzzle. By studying them, we can unlock some of the universe's greatest secrets.